In this video, I'm going to talk about the difference between systematic and random errors in the context of archery shot placement. Figure 1 shows a typical shooting result for 144 arrows, where each dot represents an arrow location. Shot at an arrow target where the numbers represent essentially the rings. So we're starting with the 10 ring in the center and moving outward. We're going to begin by defining the X as the center of the target or the center of the arrow patterns. We call this the centroid, and it's the average X position and the average Y position. And in this model, the centroid is indeed centered on the middle of the target. Would expect that all of the arrows would hit the center of the target, the X, if you were a perfect archer. And we know that this is the case because we can build shooting machines which take out the human variability, and we can place arrows repeatedly back in the same hole many, many times. And however, in the real world, in the hands of real people, in a field with real wind, we actually experience random errors, which can be described by a standard deviation. And these random errors influence our shots in both the X and Y dimensions. And so the red curly brackets represent typical random errors that you might expect for a reasonably good archer. And this random error is plus or minus 2.5. And so the result of this is that 66% of the arrows fall within this this band. In the X, you'd expect, again, 66% to fall within this band of the Y. But the net result is that we end up with this distribution of shot. So here's an example of two archers. One that has a very nice tight group, let's call that the blue archer, that's centered on the center of the target. And then another archer that also has a nice tight group. In both cases, the standard deviation is a half. But the red archer's bow is incorrectly aligned, and as a consequence, their centroid is shifted to the right. So it's on the edge of the 10 ring at the 3 o'clock position. So if your shooting pattern was this good, it would be an easy matter to determine that your sights were off and make that correction and move the red group on top of the blue group for maximum performance. In the real world, our shot distribution looks a little more like this. Again, I have the red archer and the blue archer. The red archer is shooting the centroid, is shooting with the centroid in the middle, and it has a standard deviation of 2.5. The blue archer is actually shooting with a standard deviation of 2.5. So their random errors are the same, but the centroid is shifted. And it's only through careful statistical analysis that you'd probably be able to determine that this person is shooting 1 unit to the right. So they would move their sight pins to the left to correct for this. And finally, let's take an extreme example. In this case, the blue archer has a nice tight pattern centered on the center of the target. A very precise and accurate shooting pattern. And we can contrast this to the red archer that's clearly having a bad day. They are experiencing significant variations in the Y. So the standard deviation in the shot pattern in the vertical is 2.5. They're doing better in the horizontal. So this is an extreme case. Their distribution is on the order of a half, but the centroid of this pattern is also shifted 1 unit in the vertical and -2 units in the horizontal. So again, an analysis of all of the red shooters' arrows would tell you two things. It would tell you that the sights are off and that they need to be moved down and to the right. And it would also tell you that the archer has a high degree of variability in the vertical and would want to work on their form to reduce that variability, and could try different techniques, track that variability, and see which techniques result in tighter groups.